Hello and welcome to the Stephen Mendes channel. In this, our continuing series on the HP50G calculator, we are going to be looking at customization today. It's the user keyboard. So let's just explain. When we turn on the calculator, what is shown under here on this line is the various menu items which we can select with these 6 soft keys. So basically, the calculator works because depending on which of the modes we choose, whether we're doing graphing, whether we're doing complex numbers, whether we're doing matrices, whether we're doing algebra, we change under here and we have a menu of basic commands as opposed to a menu of variables. The variable menu is always accessed using the var key. But when we select these other keys, like as you can hear, the various solvers, or we go to the arithmetic, the finance, the matrices and so forth, we have a situation of different items appearing on our soft menu, which in most cases is just commands. The whole thing about the calculator is trying to minimize the keystrokes that you have. So if you have a command that's going to be 7 or 8 alphabetic characters to type in, you're going to want to find a shorthand way to get it in. Now if it's a very seldom used command, it probably is worth it just to go to the catalog, put in the first letter, scroll down with the arrow keys, find the command and press OK. If it's a command that you want to use on a regular basis, like every day, then it's better to either have a dedicated key for it or to have a soft menu where you can access that item particularly quickly. What Hewlett-Packard has done is to create a user keyboard which is accessed by pressing the white left shift button and the alpha. Here you see it is user in white. And when you do that, you can have each of these keys here remapped to a different behavior. Now the keys are numbered by the row and the column, and that is how you assign a specific command to a specific key. Now you can also assign not only commands, but you can assign programs or functions that you have written to a specific key. So the only disadvantage with using the user keyboard is that you need to remember what you put on what key. Because once you press it, if it's a command, it's going to execute right away. And if you go and press the wrong one, well then you've only created more problems for yourself. So you need to have either a very good memory or some sort of overlay or written map that will show you what you assign to the keys. Let's go through the commands one at a time that affect the user keyboard. To find these commands, as I said, we can go to the cat and search through them. But all these other menu options here on the calculator have the keys nicely sorted depending on the functions that we're interested in. So program, see PRG up there for example, the white program written there on, to the left of the eval key. We press the left shift, which is white. We press there and lo and behold the program menu appears above there. Now we want to select modes if possible. So we don't see it right there now, so we press next. And this is actually, these keys are actually menus in their own right because they all have the little line above the first letter. So we see modes there, so we press modes, which brings up another menu here. And we want keys. See keys? So we press keys And then here is where we have the 4 things that concern the keys. We have assign, ASN, we have store keys, we have recall keys for storing and recalling keys, and we have del keys for deleting keys. So what we're going to do is, first of all, we're going to do the recall, which you can do at any time. So we just press recall keys, and lo and behold, the currently programmed keys are listed there. Now it goes off of the screen. We can press the down arrow here. That puts it all into the editor, and then we can look at all the keys and the programs and the things associated with them. And when we're done, we can make our changes and then save by pressing enter, or cancel by pressing on. So we press the on, which is cancel, and we're back there. We just delete it by doing that, and we're done. So that's how you recall keys, examine them, change them, and when you're done, you store them. So the store keys is the one we're going to use at the end when we're ready to put in what we want. But let's delete the keys that are in the calculator right now, because if you have a calculator with no keys, you want to start from the same position that I'm starting. So here we have delete keys. So to delete all the keys, all you do is put 0 onto the start, 0, and then you press the delete keys, and the 0 disappears and the keys are deleted. Now, how do we know that the keys have been deleted? Because if we press the recall keys again, all we see is an S, an empty list with S in it. That's just a list there with S. No keys are currently assigned. What does the S actually mean? The S means that we have the capability to assign all keys. We can disable keys if we want. We need to understand the key numbers. The key numbers, as I said, this would be all beginning with 1. So we would have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then we would have 2, 1, 2, 2, 2, 3. And we have 3, 1, 3, 2, 3, 3, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. We would have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. So we come down here from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. And we have the actual second number would be the column. So we would have like, this is 1, 2, 3, 4, 5 row. We'd have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. Now we have a full stop. And then after the full stop, we have a number from 1 to 6. So 1 represents unshifted, 2 represents left shifted, 3 represents right shifted, 4 represents alpha, 5 represents alpha left shifted, and 6 represents alpha right shifted. Let's take a look at the assignments which we're about to make. First of all, we have to our key assignments have to be within the curly braces. The first thing we're going to do is a small program which is going to be assigned to the row 5 first key, and without being shifted or anything, the basic function. So we just press the key. That is the key information that I was just telling you about. Now the program that we're going to assign to this key, I'm going to explain it to you. It's an if then else statement. The 17 here with the dash in front of it is a flag. We're going to make a video on the flags. The flags control the behavior of the calculator, and you can change many of the modes of the calculator by changing the flags. So what this program says, if flag 17 is clear, because the 17 tells us which flag to check for, the FC question mark checks to see if the flag is clear or not and returns true. So we check flag 17, is it clear or not? If the flag is clear, then we set it. So we have the same flag number and we set the flag. Remember, by setting or clearing, a flag is just a switch. It's either 1 which is set or 0 which is cleared. It's just a binary switch. So if the flag is clear, we set it. Otherwise, we reset it. Because this is testing it, FC, test, reads the state of the flag, SF sets the state of the flag, and 17CF clears the state of the flag. So by writing this program like this, we are actually turning that key into like an on-off switch. If the flag is set, we clear it. If the flag is cleared, we set it. So the first push of the key will set a cleared flag or reset or clear a set flag. So that's, we toggle the flag, basically toggle the flag with this little program. Now it turns out that flag 17 is the one that decides whether your calculator is in radians or degree mode. So this allows us to change from radians to degrees and back again with a simple push of a button, instead of having to go through the modes, go to the modes and change it and exit and everything. So this is actually a shortcut method of changing between radians and degrees. If it's degrees, it makes it radians. If it's radians, it makes it degrees. Now when we look at this little next little program here, we are doing exactly the same operation, but this time we're doing it with flag 16 instead of flag 17. So we're toggling flag 16. If it's clear, we set it. If it's set, we clear it. And by toggling flag 16 is actually the flag that determines if we are in rectangular or polar coordinates mode. So we quickly change the look of our complex numbers on the stack from rectangular to polar and back again simply by pressing this key, which also is a function that we want quickly without having to go to the modes to change from rectangular to polar and back again. So with these little quick programs, assign the functionality to these keys. And the next key that we're going to use is in the next row. This is in row 6, the first key in row 6. Once again, the one after the stop means that it is operating. You just press the key. You don't have to use right shift, left shift, or alpha or anything. Now, last argument is a very, very useful operation that you want to have all the time. Just that you want to be able to change your calculator from radians to polar and from complex, from polar to rectangular. You want to be able to recall the last arguments. Those are the last arguments you use with the last commands. But last argument is actually 7 letters to type, which takes time, or you have to hunt for it in a menu. So rather than hunting for it in a menu, you just push this one key and that immediately executes the last argument command, pops them back onto the stack, and we're going to show you how useful that can be in the next problem that we are going to solve. Finally, the purge. I've used the purge before in clearing variables and clearing out directories. There used to be in the 48S and SX an actual key for purge that you would just press the key on the calculator and it would immediately delete variables and directories depending upon whether you had them within braces or not. If you just wanted a single variable, you could press the single variable and deleted it. If you want to delete several at a time, you put them all in a list. Okay, the first thing we need is the braces. We get the braces here. See our different types of brackets, our square brackets, our normal curled brackets for complex. These are the square brackets for vectors and matrices. These are the normal curved brackets for complex numbers, and these are the curly brackets for lists. And right next to them are the program symbols, the double arrows. So we get the curly brackets with the white left shift key, and we get the programming symbols with the right shift orange key. So right now we want curly braces, so we press that and that, and we have a pair of curly braces here in the line, which is called our command line. In our command line, we have a pair of curly braces. It's not let on the stack. If it was on the stack, it would be in the lines numbered 1, 2, 3, 4, 5 and up. So now we have the curly braces. We now need to enter the programming symbol. So we press the orange one and boom. As you can see, we have a pair of programming symbols between our curly braces in the display. Now it's easier to read these programs if you keep them nice and neat, and we don't want to have to scroll off the edge of the screen. So we can push the return here at any time. Notice we have a sort of carriage return key here above, on the right side above the decimal point. So we press the right shift orange and the return, and that inserts a new line for us. And let's put in a couple of spaces. It ignores these when it's executing the program. We might want to insert another carriage return and a couple of spaces to make your program easy to read. And put in our number 51.1. 51.1. And then another carriage return. Remember, spaces make it easy to follow and readable and understandable, but don't interfere with the operation. It's frustrating putting it in, very slow and time consuming, and you may have made mistakes and have to go back and correct it. But when you have finished entering it, no matter how long that takes, you'll want to check it. And when you have it all looking like this, then you may press enter. And when you press enter, that puts it onto the stack. And once it's on the stack, you may now put in stokeys, S-T-O-K-E-Y-S. Now, what you can do is you can find that many ways. As I said, you can go to catalog and look for stokeys, or you can find it the way that we found through the program menu. So we'll go back, program. Remember what we were looking for? We were looking for program modes, and then we were looking for keys. And there is the stokeys right there. So we press the stokeys, and it disappears from the stack. And now if we press the recall keys, we see that it is stored. And now the functionality of our keyboard is programmed, or rather those 5 keys have been programmed. The S means that we will be able to program other keys if we choose to, using the assign function. But now to test the functionality of the program we have made, look closely at the display. The calculator is in degree mode and XYZ rectangular mode. If I press the left shift white, then I press the user, and I press the YX here, the degree changes to radians. And if I press it again, 1, 2, 3, it changes back to degrees. So that shows that the program with the first flag is working correctly. Now we press here again, and this time we press the root key here, and we see that it's changed to polar mode, and then we press it again, and it's changed back to rectangular mode. And so we can do that as often as we like, and it toggles back and forth. To show you how useful the last arguments is, let us use 2 of our complex variables that we were using in a recent problem. And we have a number of variables here. So let's take Z1 and Z2, Z1 and Z2. We've put them on a stack. Now let us multiply them together This is something we normally do with two parallel impedances. And now we would like to bring back the last arguments, those two values that we just multiplied. Bring them back here so that we can add them together. That's the power of the last arguments command. Once again, we shift to the user keyboard, which is white alpha for user. And then now we have this key here above it is our last arguments key. So you see they're back there on the stack. So all we do is add them together and then divide, and that's the fastest way to find our parallel impedance. Enter two things on the stack, multiply them, use the last arguments to bring back the two things, add them, and then press divide, and we're done. We have our answer right there on the stack. We want to get the curly braces, curly brackets there, and now we simply press the variables that we want to purge. 3, 4, 5, and 6. And we press enter. So that puts a list of the variables that we want to purge. Now remember, we created a key to purge them, and it's this key here. So once again we go user purge, and the variables are history. We'll look at the custom menus in another video. This has been quite long enough. Thanks for watching the Stephen Mendes channel, and see you in the next video.